Sorry guys, someone called me and ended my video. So I'm gonna just go on from where I left off. We were on the find the critical value. So for the F crit, I got 3.88 because you would open up your F distribution table for ANOVA, and this is basically going to be 2 over 12. So you would go across 2 and you would go down and find 12. And then you would go 3.88. We use the light one because we have alpha 0.05, and here it tells you that you need to use light phase type for critical values for the 0.05 level. So that is why we get 3.88. And then for step 3, you have to calculate. This is the the most difficult part because there's a lot of different equations that go into this. For me, I know already that we are gonna need all of these e of x's and other things that we are not given. So I do that first. I come right here, and then you have to get e of x. You have to get it for all of the equations. So all of the different groups of the different dosages. So for here, I came up here and I already did calculated all of that out. So for e of x squared, you would just do 17 times 17, 14 times 14 all across, and the same goes for this. Here I actually did it this way just because I didn't know if I was gonna have enough room on this side. I did highlight so that you guys would be able to tell which one goes to which. The no drug is orange, the medium blue, and so on. So that's what I did here. And so the e of x squared, I have all these calculated out. And then I went ahead and went up here, and the e of x is just the sum of x. So you would just add all of your original numbers. So that's what I did for all of these. I did that for here and for here. That's 100 and the 90 and the 125. Then for ex squared, you would have to find the sum of this. So you add all of the numbers that you had gotten when you squared these original numbers. So that's what I did for all of them, and I put all the information above. All of them have the same n, which is just 5. 1, 2, 3, 4, 5. So then I come back down here, and I find that our first equation is SS equals e of x squared minus e of x parentheses e of x squared divided by n. So here I wrote out them for all of them. That's why I color coded them in the same color codes I did here. And you would just do 1654 minus 90 divided by 5. The best way to do this would be 90 parentheses first, then divide, then subtract. That's what I did for all three, and I got 34, 40, and 34. And for me, I have to number each separate equation that we're going to be using so that I can remember which ones and know that they are separate and know that I need to remember those and use them when I do it on test or for homework. So I numbered that this is the first one that we would be using, and we got them already. Then right here I have that the second thing, that the equation that we would be using is the SS within, and that equals the sum of the squares, which that would be just simply adding 34, 40, and 34 that we got from this equation. So that's what we do here, and we get 108. And then our third equation that we will be using is the sum of squares between, which is the e of t squared over n, parentheses, minus g squared divided by the population n. So here I did highlight the things that we may not know, that we may not be familiar with due to that they're new from this chapter. So I did the treatment total and the grand total ET, which over here I also calculated ahead of time. This is just the e of x's, the totals added together. And then so I just plug that in, and you have to plug it in for every single condition. So here we have 1, 2, 3, and we have the 90 squared divided by 5, 125 squared divided by 5, 100 squared divided by 5, and that is due to these. So I just took these and plugged it in and got the n. All of the n was the same, and then right here we also get the g squared, 315 divided by 15. We already knew these numbers before. This was only the only real new number that we plugged in now. So then we calculate this, and then we add them together, and then we subtract. Right here, I've from all of these 1620, 125, 2000, I got 6,745, and then I subtracted it by 6,615, and I got 130. And then for the fourth equation, we have MSB equals SSB divided by DFB. So it's just plugging in answers that we got before. So we recognize this. It's the sum of squares between. The DFB would be the, I always forget this word. Why do I always forget this word? You guys know. The DFB is 2. So basically we would come over here and we would plug that in. So we have 130 divided by 2. MSW, same thing. It's SSW divided by DFW. So we have the SSW right here. The DFW is right here. So that is 12. So then we will just go ahead and divide that, and we get 9. So our answers here are 65 and 9. And then right here I noted that this is our fifth equation that we are using in this calculation step for step 3, and it is our final equation. So good job to us. And it is F equals MSB over MSW. Again, it is just plugging in the things from what we just did. So it would be F equals 65 divided by 9, and we finally get 7.22. And now we can finally compare the critical value with our value that we've gotten. So as 0.22 is a lot bigger than 3.88. So our last step would be reject or to fail to reject. And of course, we know that we are going to reject the hypothesis because this number is a lot greater than our critical value that we obtained before. So I wrote for part A that drug dose does in fact have a significant effect on performance. And for part B, so let's show you here, the question is asking us what test would a researcher use to compare the no drug group to the high dose group? So here I wrote that. I said if a researcher wants to compare the no drug group to high dose group, they would use a post hoc test. The post hoc test is within the ANOVA. It is what we do after the ANOVA. So within the text, it is because when you reject the HO and have more than 2 categories or conditions to compare, then you would use HO to find exactly where the significant difference is. So here we are trying to see if there's more of a significance with the no drug or the no drug dose or the high dose. So here we will know exactly which one has a significant effect. So that is why we use the post hoc test to see which one is more significant. And then for C, it asks us here to write the results of the ANOVA as they would appear in a research article. So I put the results of ANOVA as they would appear in a research article. There is a significant difference observed of the effect of drug dose on performance. And then you have to write out the F of 2 and 12. 2 is the K, 12 is the 12 is our DFW. So then we get 7.22, which is our final critical value that we obtained. And of course, we are doing P less than 0.05 because we rejected the hypothesis. If we failed to reject, it would have been the other way. And 0.05 is, of course, the alpha that we were given at the beginning. So yeah, that's how I did it, guys. Sorry that my video is a little long. I hope you guys were able to understand it and can maybe use anything that I did in your work or on your final exam. Good luck on the final exam, guys, and good luck to anybody that's transferring. Congratulations to anyone that's graduating, and yeah, bye.